Good morning, students. Today we are going to see Unit 4 Operating System. My name is Praveen Awad, Department of Computer Engineering, Sri Chhatrapati Shivaji Maharaj College of Engineering, Ahmednagar. In this Unit 4, we will cover following points: importance of software and computer software, what is meant by operating system, need of operating system as an external machine, operating system as a resource manager, history of operating system, basic functions of operating system, and what are the different services provided by operating system. So first of all, what are the importance of software? We know that with the help of software, a computer can store, process and relative information, find spelling error in manuscript, play adventurous and energy in many other valuable activities. Normally, computer software can be divided into two parts. One is system software and another is application software. System software is nothing but these are the program which manages the operations in your computer system. For example, compiler, loader, linker. Application software are nothing but these are the programs which solves problems related to your end user, like Microsoft Office, Paint, PowerPoint, as like that are example of your application software. So normally what is mean by operating system? The most fundamental of all the system program is nothing but the operating system, which controls all the computer resources and provide the base upon which the application program can be written. What is need of this operating system? Normally, modern computer system is a complex system. Writing programs that keep track of all these components and use them correctly is an extremely difficult job. So many years ago, it becomes clear that some way had to be found out to shield programmers from the complexity of the hardware. So the way that has evolved is to put a layer of software on top hardware to manage all part of system and present the use with an interface or virtual machine that is easier to understand and program. This layer of software is nothing but your operating system. A computer system consists of hardware, system program and application program. Hardware is nothing but part of your operating system, machine language, microprogramming and some physical devices. System program consists of like compiler, editor, linker, command interpreter. Application programs are consist of like banking system, airline reservation, adventure games. In this way, these are the structure of how your hardware, system program and application programs are assembled. Operating system and extended machine. As we know, simple high-level abstraction to deal with this. The program that hide the truth about the hardware from the program and present a nice simple view named files that can be read and write is nothing but your operating system extended machine. Operating system working as a resource manager. Like the job of operating system is to provide various programs an orderly and controlled allocation of processor, memory and input-output device. Example, imagine what would happen if three programs running on some computer all tried to print their output simultaneously on the same time. So to keep track of who is the using resource first, grant that resource request and to account for uses and to mediate conflict requests from the different programs and users. Now we will see the history of operating system. Firstly, digital computer are designed by scientist Charles Babbage. The first generation 1945 to 1955 uses vacuum tube and plug board. During that time they are using some vacuum tube and plug board for performing different operations like slower programming languages where since cosines. The second generation is between 1955 to 65. They are using transistors and batch system. Machine were locked away in special air-conditioned computer room with staff of professional operators to run that system. Programmer would first write program on paper, punch it on card, bring that card down to the input room and hand to one operator. When computer system performs job it was currently running, an operator would go over to the printer and tear off output and carry it to output room so that programmer would collect it later. Much computer time was wasted while operators were walking around the machine. The solution adapted was batch system. The third generation is between 1965 to 80. That time they are using ICs, integrated circuit and multi-programming. By the early 1960s, computer manufacture had two distinct and totally incompatible product lines. Default-oriented used the numerical calculation. Character-oriented used for the tab sorting and printing. IBM introduced 360 was the first major computing line to use integrated circuit. Multi-programming, I like that. The fourth generation is between 1980 to 1990. Personal computer. It is also known as large-scale integration circuit. Chips containing thousands of transistors on square centimeter of silicon. Widespread availability of computer power. High interactivity computing power with excellent graphics. MS-DOS or Unix operating system was used during that time. Network operating system, distributed operating system was useful. Some of the functions of operating system: job accounting and log maintenance, memory management, fault tolerance management, command interpretation, execution, communication, process management and scheduling, device management, file and data management. Services provided by operating system. Operating system providing different services for end user like program development, access to input-output device, program execution, counting, error detection and response, controlling access to file, system access. These are some of questions. Now we will move to next topic in fourth unit operating system, that is process management. In this point in fourth unit we will cover what is meant by process, what is process state, what are the two-state process model, process creation, termination, 5-state model of process and transition, process control block and thread. So first of all, what is meant by process? Process is nothing but your end user program, or process by itself is not a process, it is a program that is passive entity. Process is an active entity with program counter specifying the next instruction to execute and set up associated resources. Example, user may invoke several copies of editor program. Process state. For the program to be executed, process or task is created that from the processor's point of view, it executes instructions in some sequence directed by the changing values in the program counter register. From the point of view individual program, its execution involves in sequence of instruction within that program. Process state continue. Characterize the behavior of individual process. Trace. Characterize the behavior of processor. Some snapshot of example of execution that address main memory, program counter, is like that. These are some combined trace of process, how process is identified or traced with the help of their address. A two-state process model. Entering, that is are not running, dispatch, pause and running mode, and finally execute. Responsibility of operating system that controlling the execution of process, determining the interleaving pattern for execution, allocating resources of processes. These are the two state of process model like entering, queue, dispatch, processor and finally execute. Process creation. How your process is created. Firstly, new batch job, interactive logon created by operating system provide services, swap by existing processes. Process termination. Process termination is nothing but the part of executing final step or termination of that process. These are the 5-state model. When process is generated, during that time that is generated from new, then it is admitted to ready state for ready for execution. Then it will dispatch to running mode, that is currently running going on your operating system. Sometimes it is get blocked or waiting stage for completion of running process, and after that it will be exit or terminated process. Process control block, PCB. Process control block is nothing but the part of your process which performing role of program code and data associated with that code. Mostly we refer to this executing entity as a process. Process can be uniquely characterized by a number of elements. Process control block. Process control block consists of identifier, status, priority, program counter, memory pointer, context data, input output state information, accounting information. So processes and thread. These are the two characteristics that resource ownership and scheduling. Multi-threading. It refers to the ability of an operating system to support the multiple concurrent paths of execution with single processor. Traditional approach of single thread of execution per process, in which the concept of thread is not recognized, is referred to as a single threaded approach. Thread and processes, one process of thread and multiple process thread. Multiple process thread. Types of processor scheduling: long term scheduling, medium term scheduling and short term scheduling. In long term scheduling, the decision to add the pool of process to be executed. A medium-term scheduling, the decision to add the number of processes that are partially fully main memory. Short-term memory or short-term scheduling, the decision as to which available process will be extended by the processor. General categories: primitive, non-primitive. Some of the different algorithms related to the scheduling algorithm: FCFS, round robin, and priority. And these are some questions related to your process. Now in unit 4, the next topic we are going to cover, that is known as deadlock. In this point we are going to cover different points like what is meant by deadlock with example, resource allocation graph, necessary conditions for deadlock prevention, avoidance, detection and recovery. So what is the principle of deadlock? Deadlock can be defined as the permanent blocking of set of processes that either complete for system resources or communicate with each other. A set of processes is deadlocked when each process in the set is blocked, awaiting an event that can only be triggered by the another blocked process in set. Deadlock is permanently because none of the event is ever triggered. A deadlock involves conflicting need of resources by two or more processes. Example, traffic deadlock. These are the some of example of deadlock possible and deadlock evidence. Example, suppose process P, process Q, gate A, gate B. At a time both are required same printer. That time how deadlock are avoided, that we will see later. Resource allocation graph. It is useful tool characterized in allocation of resources to process is the resource allocation graph. It is directed graph that depicts a state of system processes with each process and each resources represented by name. A graph edge is directed process resources indicated resources that has been requested by process but not yet granted. Within resource node, do each dot is shown for each instance of that resource. A graph edge directed from a resources node dot process indicate a request that has been granted. These are some of example resources allocation graph. That is, particular process is requested, hold, and as like that. Condition for deadlock. There are conditions like mutual exclusion, hold and wait, no preemption, and circular wait. In mutual exclusion, only one process may use resource at a time. In hold and wait, a process may hold allocated resources while awaiting assignment of the other resources. No preemption, no resources can be forcibly removed from the particular process. And in circular wait, a closed chain of process exit such that process hold at least one resources needed by the next process in the chain. Deadlock prevention. Indirect method. Deadlock prevention is to prevent the occurrence of three necessary conditions. Direct method is to prevent the occurrence of circular wait. That is mutual exclusion, hold and wait, no preemption, and circular wait. Deadlock evidence. Two approach for deadlock evidence. Do not start a process if its demand might lead to deadlock. Do not grant an incremental resources request to a process if this allocation might be lead to deadlock. Deadlock recovery. How to recover deadlock from this? Following are the possible approach for recovery once deadlock is about all deadlock processes. Backup each deadlock process to some previously defined checkpoint and restart all processes. This requires that rollback and restart machine to build into the system successively about deadlock process until deadlock no longer exists. Detection algorithm needs to be re-invoked. Successively preempt resource until the deadlock no longer exists. A process that has a resource preempted from it must be rolled back to a point prior to its creation of that resources. These are the some of questions related to deadlock. So in this way we have covered unit 4, that is operating system. Thank you so much.